Hello guys, so we are back again and on study online, and today we are going to do third session of problem solving on sequence and series, and we were done 40 questions okay till now, and we are continuing this problem solving course with 41 question of exercise whose answer are single correct. Okay, so the 41 question says the sum of 20 terms of a series of which every even term is 2 times the term before it and every odd term is 3 times the term before it. The first term being unity is, okay, options are: first option 2 by 7 into 6 power 10 minus 1, second option 3 by 7 into 6 power 10 minus 1, third option 3 by 5 into 6 power 10 minus 1, and fourth option none of this. Now let's understand the question and solve it. First it is saying sum of 20 terms of a series. Every even term is 2 times. Okay, I came to know that even term means, okay, even term means even position term. Okay, so you must understand the language. Okay, language is very important. Even term, okay, even position term. Okay, so is 2 times the term before it. Okay, means if the first term second term is even position, okay, so it will be twice the whatever the first term is, and every odd term means third position term is 3 times the term before it, means it will be 3 times the even position term. Okay, simple. And the first term being unity means 1, so the first term is 1, second term is 2 twice the term before it. Okay, term at even position. Third term is 3 times. Okay, so after this you can clearly understand this will be again third position, this will be 2 square into 3. After this 2 square into 3 square. After this 2 square into 3 square. After this 2 cube into 3 cube plus 2 power 4 into 3 power 4, 3 power 3, 2 power 4 into 3 power 4, 2 power 5 into 3 power 4, 2 power 5 into 3 power 5, 2 power 6 into 3 power 5, 2 power 6 into 3 power 6, and 2 power 7 into 3 power 6. Okay, and 2 power 7. Okay, 20 terms. Okay, we have to take 20 sums. Okay, 20 terms, 2 power 7 into 3 power 7. Okay, I should write the final, means the last term directly. Okay, in this pattern if I observe, I was writing the whole term. The last term will be 2 power 10 into 3 power 9. Okay, now it is 20 term. Okay, this is 0 1 2, like, okay, 1. Okay, we can begin consider it from here. Okay, you can take 2 terms, okay, extra. So 1 2, then you have to wait twice. Okay, so 1 2 3 4 5 6 7, so it will go on till 10. Okay, for 20 terms. Okay, 2 power 10 into 3 power 9. So how we can solve it? So okay, let's write it on 2 power 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16, 2 power 8 into 3 power 7, and then 2 power 8 into 3 power 8 plus 2 power 9 into 3 power 8, and the last one I will add here, 2 power 9 into 3 power 9, and then 2 power 10 into 3 power 9. Okay, so these are our 20 terms. Okay, in this question means it is difficult to write directly the 10 term. Okay, that's why I was writing this thing. Okay, now to get its sum, it is very important to differentiate the series, means you can categorize these numbers can make a set of this type of series, these numbers can make a set of this type of series, like that. Now if we observe more clearly, okay, we can make a series. Okay, a series whose powers are same, like here 2 power 3 into 3 power 3, 2 power 2 into 3 power 2, here 2 power 3 into 3, 1 power, same power. okay, and 1 will also come because it is 2 power 0 into 3 power 0, so 1 into 1, which is 1. Okay, now the next series which we can make is that odd power series. Okay, 1 3 power 0, okay, like that stuff. 2 power 1 2 power 2 into 3 power 1, okay, like that we can make a series. Okay, so now let's make a series. So let's break them. 1 into 2 into 3, okay, then plus 2 into 2 into 3 into 3, then 2 power 3 into 3 power 3, then 2 power 4 into 3 power 4, and so on. What is the last common term we know? 2 power 9 into 3 power 9. Now plus, this is our one series. The next has difference powered series. This is 2 into 1, 3 into 2, or sorry, 2 power 2 means this one. Okay, then we can write the next one, which is 2 power 3 into 3 power 2. Okay, like that it will go on till what? 2 power 10 into 3 power 9, the last term. Okay, so these are the three series. Okay, now we want to write the sum of these. Okay, the first series, it begins from 0 and ends till 9, so there are total 10 terms. Okay, the first term being 0, 6 power 10, the common ratio is 6 minus 1 upon 6 minus 1. Similarly here, okay, we will play in what terms. Okay, we should observe that which terms are in AP and which terms are in GP. So here, okay, this is 2, okay, this is 3, this, okay, how we can play it. Okay, let's think how we can. Okay, this is 2, then 2 square, then 2 cube, okay, and so on till 2 power 10. So this can form a GP and this can form an AP, provided a, okay, 3 power, this will become 1, this should become 2. Okay, this is 2. Okay, first 2 power 0. Okay, we have missed any terms or what? 3 into 2 power 2 and okay 2. So have we missed any term? Okay, here if we observe more clearly the common ratio which we should take, okay, here if I consider this is as 2, okay, my first term is 2, okay, next term will be 3, and after this, okay, we should take the term like this. Now listen, analyzing this series is difficult. Okay, I want to explain you in the simplest possible way. Like this will be 2, okay, and because we can see 6 power 10 in all of these, okay, it should have also have 6 power 10. Then to make that, okay, I have to make it here what 6. For that I require 2 into 3, so 2 will be left. Okay, 2 will be left and 2 into 3. Again here we will do what? This will 3 into 2. Okay, this ratio will increase. Okay, 2 square, okay, 2 into 3. Now 2 cube into 3 square, 2 cube into 3 square, 2 cube into 3 square, and so on it will go on. 2 will be, okay, here 2 was there, okay, 2, this will be 6, okay, for that 2 will move out, and again here, okay, it will be multiplied with 2 into 3, then it will become 3 square, this will become 2 cube, okay, then it is not forming GP, that's the problem. These are all forming a GP, but this is not, means it's not in GP. Okay, so what we can do here, it is 2, this is 2 into 3, okay, 6. Here if I take 2 common and this is multiplies twice, so 3 into 2 and 2 into 3 into 2, and so on. Okay, if I take the last one 2 common, this will be 2 power 9 into 3 power 9. Okay, so here also the common ratio has become 6 and we can take 2 common, which will give me 1 plus 2 into 3, then 2 into 3 the whole square, and so on till 2 into 3 power 9. Okay, hope you have understand this step. Okay, that how we take the common term. Okay, now here we have 6 power 10 minus 1 upon 6 minus 1, and here 2 into 6 power again 10 terms minus 1 upon 6 minus 1. Okay, so in the next step, okay, let me take the next page here. Okay, here I am writing it. Okay, so I will take 6 power 10 minus 1, that is very obvious, and 6 minus 1 will be what, 5. Okay, that will also come common. The left thing will be 1 plus 2, which will be 3 by 5 into 6 power 10 minus 1. Okay, so now let's revise the question. The question was not an easy question. The first thing, it was difficult to predict the last term. In the first starting you can start writing this term, that is very easy, but after soon you will realize a pattern. But predicting its last term, it's not an easy task. Okay, then you have to analyze that this series can be solved by breaking it into two types of series, like series which have same power terms like this one, first one, and these terms which can have 2 can be removed, and thus 2 can be taken out separately, and the left will be 6 as a common ratio GP. We did that and then we got the answer. Okay, that was the main pattern which you should follow. Okay, now let's move on to the next question. Okay, the next question is this question. Okay, which says let A belongs to 0 comma 1 where 1 is included because it is a closed bracket. Okay, and then the equation A power 2008 minus 2A plus 1 equals to 0, and S is equals to 1 plus A square, and so on till A power 2007. The sum of all the possible values, okay, of S is. Okay, now we want to find the possible values of S. Okay, since 1 is included in A, when A value is equals to 1, okay, we want to find the possible values. When A will become 1, S will be what, 1 plus 1 till what, 2008 times. Because at 0 it will be 1. Okay, this will be 1. Okay, this will also be 1, but all this will add up and give me 2008, because at this 0 will be, it is starting from 0, that is what I am meaning. Okay, so 2008. So 1 as we are got, but when A is not equal to 1, then we will what do? First we will try to get its sum, which is first term is 1 into A power 2008 minus 1 upon A minus 1, simple. And after this, from this equation which they have given here, I can see A 2008 is nothing but minus 1 plus 2A, right? I just move this value, then I will write minus A plus 2A minus 1 upon A minus 1, which will give me 2. I will take common, A minus 1 upon A minus 1, which will lead me to 2. So my S2, okay, I will call it as S1, is 2. So S, which is the possible value, sum of all possible value, will be S1 plus S2, which will be nothing but 2008 plus 2, which will give me 2010. Okay, so 1 is the answer. Okay, so here the first question, that after observing that A belongs to this thing, okay, A can have value between 0 to 1, or it can have one value, because 1 is included in the bracket. Okay, so we consider the two possible cases, that it can be between 0 to 1. Okay, and which was the second case, and first case when it is equal to 1. Okay, because 1 is included, otherwise the answer would come from this only. Okay, we would have not taken this one in consideration. Okay, so hope you have understand this process. Okay, that's why they were given this one. Okay, so we are done with question number 42. Now let's move on to question number 43. Okay, which says in a geometric series the sum of term is A and common ratio is R. Okay, if Sn, common ratios, if Sn denotes the sum of n terms and un is equals to summation n is equals to 1 to n sn, then rsn plus 1 minus run equals to what? 0 n nar. Okay, what is the possible value? Okay, so first it is telling a geometric series. Okay, ar square and so on. What is the last term? Ar power n minus 1, which is Tn term. Now can we get its Sn? Very easy. A into r power n minus 1 upon r minus 1. Okay, when will I get its sun? Okay, I have got my Sn, so I will substitute that, but for un I have to put it this thing in summation. Okay, so let's put this thing. When we for un we will put this thing in summation, which will be n1 to n a into r power n minus 1 upon r minus 1, right? We will take 1 upon r minus 1 a common. Why? Because it is for n and here is n. These are will be constant for it. N is equals to 1 to n r power n minus 1, then a by r minus 1, n is equals to 1 to n r power n minus n is equals to 1 to n1, which will give me my final answer a upon r minus 1, 1 plus 2 plus till till n, which will be nothing but this thing. If you observe this thing, this is like giving a series. Okay, like this, but just the difference it would not have a. Okay, a it's outside. Okay, let me open the series. 1 r square and so on till r power n, and here it will be n. Okay, and this is both outside the bracket. Okay, now let's solve this here. A upon r minus 1, it's means r into r power n minus 1 upon r minus 1 minus n, which will give you that r into r power n minus 1 upon r minus 1 the whole square minus an upon r minus 1. Okay, so after this what we can do? Okay, after this what we can do? we will substitute the value of this un in what? This un value here, because we want this value, which is r sn plus 1 minus r into un. R into sn is nothing but a into r power n minus 1 upon r minus 1. R minus 1 minus r will be what? Into un will be nothing but 1 minus r into r r power n minus 1 upon r minus 1 the whole square. 1 minus r will give me an. Okay, this will cancel out, giving me 1. Okay, when I multiply this will cancel out. Okay, the next step I will going to write this is that only. Okay, and this a which was outside will multiply with both. Okay, this it will multiply with this thing only. So r power n minus 1 upon r minus 1 minus, okay, minus, okay, so a into r plus a into r. Okay, okay, a into r power n minus 1 upon r minus 1 will be left minus an. Okay, so we applied this thing, we just put the r, we got the value, multiplied the things. Okay, and then substituted here. Okay, when we multiplied the thing, we came to know that this term, okay, this 1 minus r, okay, a into r minus n will multiply with this, give me, okay, we can do one thing. Okay, I think we have done a mistake. No, we have not done any mistake. This rn will cancel out this one, and a will be multiplied, right? And any other mistake, geometric series is r, okay, r power n, okay. So I think we are doing a mistake. Okay, the mistake is like this, that we cannot cut this thing with this, because this is 1 minus r and this is r minus 1. Okay, so we will take a minus outside, which will give me this minus, okay, and then this will cancel out. Okay, so and then this will cancel out, giving me my final answer. Okay, giving us a final answer. Similarly here will happen when it will move inside, it is 1 minus r, so this will become plus. Okay, although for cancelling out I will take minus outside, which will make it plus. So the final answer is an. Okay, how came out? When I multiplied this thing, okay, this thing, to cut this, it just given us a minus, for which it became negative and this became positive. So these two cancel out and the left thing is an. Okay, hope you have understand this problem. This problem was just on the basis you should get Sn, and then from applying Sn here, putting Sn value, you should use the summation properties and use the summation of number properties to get the answer, and then put it and get your this value. Okay, which was third. So third is the answer. Okay, third is the answer. Now let's move on. Okay, so this is the next question, which is question number 44, which says let s belongs to 0 to pi. Okay, 0 to pi denote the set of values of x satisfying the equation 8 power 1 plus mod cos x plus cos square x plus mod cos cube x, and so until infinity, is equals to 4 cube. Okay, now we know, okay, then s belongs to that. Okay, the options are making it more worst. Okay, so I'm not going to read the option. Now we know the cos x range, it is nothing from 1, okay, to minus 1. But when we apply mod, the function graph shifts upward, okay, above positive x-axis, due to which mod cos x is nothing but from 0 to 1. You will study it graphically in function chapter. Okay, so what we are going to do after this is that, okay, this thing, okay, this, when we apply, it is greater than equal to 0, but it is between 1 to 0. Okay, after doing this, what we can do, okay, we got a range of cos x. Okay, it is between 0 to 1. Then we will get the value of this series. Forget this 8, just first get this value of this series. Okay, cos x mod plus cos square x. Okay, doesn't matter you write mod or not. Okay, so when I get its value, it is nothing but cos power, okay, 1 upon, okay, it is infinite, 1 minus cos x mod cos x, since 1 cos x is there, not even power cos x, is equals to 4 power cube. Okay, and we know this. Okay, this is 8 power. So what manipulation we will do? We have put the sum in 8 power, which was there in given in the starting. Okay, so we will do, we know 4 power 3 is nothing but 64, but we know one more thing, it is 8 square. Okay, so 8 power 1 by 1 minus mod cos x should be 8 power 2, which is giving me, it should be equal to 1 upon 1 minus mod cos x should be equal to 2, which will give me 1 is equals to 2 minus 2 mod cos x, which will give me 2 is equals to minus 1 minus 2 mod cos x, which will give me my final answer, cos x is equals to 1 by 2. Okay, which is when I remove the mod. Okay, when there is mod, when I remove the mod, you know the basic property of mod, this will plus minus 1 by 2. Okay, so we want the cos positive 2 by 1 by 2 and negative 1 by 2. Okay, the positive one is very easy. Okay, you will get it. Okay, you know already. Okay, it is pi by 3. Okay, now for negative one, which is cos x is equals to minus 1 by 2. Okay, I will teach these things in trigonometry section when we come there. Okay, in very detail, very detail. Okay, but for now I will tell you the trick. Okay, for this thing only. This is graph. Okay, cos x here is positive, this is negative, and this is negative. Okay, and it is in between 0 to pi, so I will take this one negative. Okay, and this is what first we know its value, we know it is what pi by 3, it means 60 degree. Now we want this angle. Okay, for this angle, if I subtract it from pi, if I subtract this angle, okay, if I subtract this angle, okay, pi by 3, then this I will get the left thing, okay, which is the required thing. So for cos x is equals to minus 1 by 2 is nothing but pi minus pi by 3, which is nothing but 2 pi minus pi by 3, which is nothing but, okay, sorry, 3 pi minus pi by 3, which is nothing but 2 pi by 3. Okay, so cos x. Okay, if anyone tells you to find the negative one, just add pi plus pi by 3. Okay, and so on. So in this way, okay, we will study it in more detail. So the two answers are 2 pi by 3 and pi by 3. So fourth is the answer. Okay, now let's move on, which is question number 45. Okay, this is the question. Okay, let me get the page. Okay, this is the question. Okay, now the question says, okay, if mod A is less than 1 and mod B is less than 1, you know this condition are for GP infinite series, very obvious. Okay, so they will not give you a hint that it goes to infinity. Further on, then the sum of the series 1 plus a into b plus 1 plus a square into b square and so on till infinity is what? Okay, that is what they are asking. So for the sum, I need the Tn, and after knowing the Tn, I can apply t is equals to n is equals to 1 to infinity, because they have given us the hint. Okay, the last term will be what? A square. I know this will go on. Okay, and the last, since it is beginning from 0, it should have end. Okay, for it, okay, beginning from, it will go to infinity, but we will consider it like that. Okay, and we will just get its sum. Okay, not a big thing. Okay, so b power n minus 1. Okay, it is also beginning from 0. So after doing this, okay, I will get its sum. Okay, if I calculate its sum of n terms, okay, it will go on till n terms. Okay, but for solving, okay, I cannot directly take I am telling that in that way. First A and B, okay, they are telling less than 1. Okay, it gives you a hint that they are tending to infinity. Okay, that is the GP condition. But here we want to find the Tn term. For that we will consider nth possible condition, so we have considered that. Okay, but why we are writing here infinity? Because they have given that mod A and mod B, okay, they are less than 1, that's why. So for calculating it, okay, we will use the Sn formula for n terms, okay, not for infinite one. Okay, so here if I use that 1 into a power n minus 1 upon a minus 1, here we will use b power n minus 1. Okay, summation will remain as it is. Okay, and one more thing, they have given mod a less than 1. Okay, so the thing that we will write it like this: a power n upon 1 minus a. Okay, since it is less than 1 to infinity, b power n minus 1. Okay, so after this, what we will do is we will separate out the things by multiplying this with b power n minus 1. So b power n minus 1 upon 1 minus a power n into b power n minus 1. Summation will be there in both one, infinity, and similarly here n is equals to 1 to infinity. Okay, so now let's solve this. 1 by a will move out. That is very obvious because n is here. Okay, so 1 minus a. Okay, and this when we open, this is nothing but 1 plus b square and so on. Okay, it will go till infinity. Okay, it will go until infinity. Minus, here we will take 1a common, which will give me n is equals to 1 to n. Since I have removed 1a, a power n, a into b power n minus 1. Okay, now I can open it, which is nothing but what? Okay, it will be what? N minus 1, so it will be 1 ab and so on till we know the last term, ab power, okay, till infinity. Okay, till infinity. Okay, and after this thing we will do what? Okay, here also 1 minus a will be there here, and we will take 1 minus a common. 1 minus a. Okay, I think we have forgotten. Okay, now we will take the sum 1 upon 1 minus b, and here when we take the sum, okay, consider this thing I am writing here. Okay, minus is here, a upon 1 minus a, this will be 1 upon 1 minus ab. Okay, so let's solve this here. 1 upon 1 minus a into 1 minus b minus a upon 1 minus a into 1 minus ab. Now to solve this, okay, we will multiply it. Okay, we will multiply this thing with 1 minus b and this thing with 1 minus ab upon 1 minus a into 1 minus b into 1 minus ab. The denominator will become same, giving me here a into 1 minus b. Okay, so which will make me left with 1 minus ab minus a plus ab upon this thing 1 minus a, 1 minus b, 1 minus ab. So this will cancel out, giving me 1 minus a upon 1 minus a into 1 minus b minus 1 minus ab. Okay, so after this step let me solve here. Okay, I solved a different. 1 minus a will cancel out with 1 minus a, giving me my final answer 1 minus b into 1 minus ab. Okay, so hope you have understood. First let me tell you, since they have given this condition, that's why we are taking it to infinity. Okay, that is the very important thing that you need to understand. After that, for sum we need to find the tn term. We have found the tn term. At tn term this will be till n term, which since it is beginning from 0, it should be at n minus 1, the last term. Since this is also b is beginning from 0, it should be also be from n minus 1. Second thing, now here we are not opening it, it is already opened, then we are taking its sum and it is still n minus 1, then we will apply the Sn formula for n terms. Then we had applied that, fine. Then we have separated b, multiplied it with b power n minus 1. We got this thing, this will open, then it will go till infinity because the summation is till infinity. Here when it will open, it will go till infinity, but here the trap is a is till n, so we have taken 1a common. Then a power into b power n minus 1, the power will become same, due to which it will become till n. Okay, we will open it and then it will goes to infinity, and then we calculate sum of infinity terms of a GP and then applied the formula, did the manipulation and got the answer. Okay, now let's move on, okay, to the next question, which is question number 46. Okay, which says as follow. This is question number 46. Okay, which shows the value of 0.2 power log 1 plus 1 by 4 plus 1 by 8 and 1 plus 16 till so on. Okay, and so on till under root 5. Okay, base under root 5. Okay, so first let's find the sum of this 1 by 4, 1 by 8, okay, 1 by 16 and so on. Okay, and it is till infinity. Okay, So we want to find it till infinity, which is nothing but the first one is 1 by 4. The common ratio is nothing but 1 by 2. Okay, so this is 1 minus 1 by 2, which will give me my final answer as 1 by 2. Okay, 2 will multiply, 2 will cancel out, giving me my final answer. Okay, 1 by 2. Okay, I got my common ratio. Okay, after this what I can do is that this 0.2 can be written as like this 1 by 5. Okay, 1 by 5. Okay, and this thing under root 5. Okay, I can write it as 5 to the power 1 by 2. Okay, and this thing I can write 1 by 5 as 5 to the power minus 1. Okay, so see this, what manipulation I'm doing. Algebra is all about manipulation. 1 by 5 log 5 power 1 by 2 into 1 by 2. Okay, this will be what, 5 power minus 1. Okay, this thing, okay, we can move it. Okay, that is the property. Okay, that when it is when any number is like this, we can move it here. Okay, which will give me minus 1 into, okay, just reverse will happen, 2 into, okay, if it is 1 by 2 it will become 2. If it is 2, then it would have become 1 into log 5 to the base 1 by 2. Log 1 by 2 to the base 5. Okay, this gives me minus, okay, minus log this thing 5, okay, minus 2 log 5. Okay, 2 power will become minus 1. Okay, this can do same like this here, like we did with 1 by 5. Okay, and this we can move to its power, which will give me 5 into log 5 to the power 2 by 2, which is nothing but this will become 1. When log bases are same, it becomes 1. Okay, power and base is same, so it will become 2 square 4. Okay, so 4 is the answer, so 1 is the answer. Okay, this question was more log related than sequence series. Just some finding was related to log, some finding was related to sequence and series, and rest all was about your logarithm. Okay, now let's move on. Okay, this is the next question, 47th, which says if x is equals to 9 power 1 by 3 into 9 power 1 by 9 into 9 power 1 by 27 into and so on, y is equals to 4 power, okay, 1 by 3, okay, into 4 power minus 1 by 9 into 4 power 1 by 27 and so on, and z is equals to summation r is equals to 1 to infinity 1 plus iota power, okay, and the whole minus r. Then argument x plus y z. Okay, you know the argument formula it is used. Okay, this is the formula which they use, okay, to find the argument. Okay, we will discuss this formula, okay, after getting the answer. Okay, y by x or x by y. Okay, let's check first. Let's solve this. Okay, now it also depends whether it is plus or minus. Okay, that's also okay. So if it is minus, then minus comes out. Okay, now what we can do is, okay, get the sum. It is till infinity, then 9 power 1 by 3 into 9 power 1 by 9 into 9 power 1 by 27 till infinity. I can write it as 1 by 3 plus 1 by 9, 1 by 27 and so on till infinity, which I can write it as 1 by 3, 1 by 3 square, 1 by 3 cube and so on till infinity, which gives me 1 by 3 into 1 minus 1 by 3, which is nothing but, so our answer is what, 3 will cancel out. My final answer will be 1 by 2. And when I will put here 1 by 2, 9 is nothing but 3 by 2, and here 1 by 2, which will give me my answer 3. So I got x value. Now for y value, 4 power 1 by 3. Okay, again this step is I am not writing, 1 by 9, 1 by 27 and so on till infinity. Here r is nothing but minus 1 by 3. Okay, so when I focus on this, 1 by 3 minus 1 by 3 square plus 1 by 3 cube and so on. Here at even power it is becoming 0. So r is nothing but minus 1 by 3. So 1 by 3 into 1 plus 1 by 3, because r is minus 1 by 3. So this will become nothing but 1 by 4. Okay, this will become nothing but 1 by 4, which will give me nothing but, okay, this will become 1 by 3 plus 1 4 and 3 3. Okay, fine. So this will be what? 4 power 1 by 4. This I can write as 2 power 2 into 1 by 4, which will give me 2 power 1 by 2, which is nothing but under root 2. So I got y is equals to under root 2, x is equals to 3, x is equals to 3. Now let me take the next page. If I open the z, okay, this was the previous question. Okay, z will be nothing but 1 upon 1 plus iota, since it is, okay, 1 plus iota the whole square and so on till infinity. Common ratio is 1 upon 1 plus iota into 1 minus 1 upon 1 plus iota, which gives me, okay, this will cancel out and the final thing which will be left will be iota, 1 upon iota. Okay, 1 upon iota, which, okay, which if I, okay, in when iota appears, you can do one thing, multiply and divide by iota, which give me iota upon, this will become iota square. Iota is nothing but under root minus 1, which will, iota square will be what? Minus 1. So this will be nothing but minus iota. Okay, after doing this we got the z thing also. Now argument x plus y into z is nothing but what? This will become argument x is what? 3, y, z is what? Minus iota, and this y is what? It is nothing but what was y? Under root 2. Okay, so we got this thing. Okay, now let's calculate the tan value. Okay, which is nothing but, okay, tan was what? Y by x. So since it is minus, the minus tan y by x. Y is what? Under root 2 by x is what? 3. Okay, so we are done with this thing. So argument is nothing but minus tan, okay, tan inverse, okay, that's what I was telling, that something is meaning tan inverse y by x. Okay, so tan inverse y by x, which is nothing but under root 2 by 3. Okay, when I observe the option, I came to know that it will be done. Okay, so when we will discuss complex number, we will discuss in much detail. Although the second chapter of Singage was complex number since, but it uses sequence and series. Okay, and complex number has many chapters interrelated. Okay, so we will do it in the end. Okay, but for now this question is very important. We have done this question. Okay, how we did it? We just substituted the value, use the basic complex number formula. Argument is equals to tan y by x, tan inverse y by x. Okay, I mostly read it tan y by x, that is the problem. Okay, so, and I also told you when it is negative, it will come out, because, okay, tan theta is tan minus theta is tan theta. Oh sorry, tan minus theta is minus tan theta. Okay, because of that. Okay, so we are done with this problem and we will move on to the next problem, and our answer is third is the answer. Okay, answer, sorry. Okay, now let's move on to the 40th question. Okay, let me take this page also. The 40th question is like this. Okay, the value of x satisfying the relation x is equals to 1 minus x plus x square minus x cube plus x raised to 4 minus x raised to 5 till so on till infinity. Now never bring this x here and make it this x 0. Okay, it will just spoil your problem, and it will make sure that if you do that, your answer is wrong. Okay, you can clearly see it is a series. Then first find the sum. Okay, x is equals to, if it is a series, I know its r is what? Minus x, 1 upon 1 plus x. Okay, it is very simple step. Okay, if I multiplied x plus x square is equals to 1, x square plus x minus 1 is equals to 0. My x is what? Minus 1 plus minus 1 plus 4 upon what? 2. giving me two values of x, minus 1 plus under root 5 upon 2, comma minus 1, okay, minus 1 plus under root 5 upon 2. Okay, so these are the two possible values of x. Okay, now we know for a GP r should be greater than 0, but this one is negative, so we will reject it, but it is positive. So x is equals to minus 1 plus under root 5 by 2. Okay, so if we observe one more thing, okay, which is very simple, okay, that is we want to find that this is the x value, okay, so this value, okay, so but our answer is in sine 18, okay, and sine 18, if I remember, this is not sine, 2 times, okay, it should be 4, okay, 2 into minus 1, why, that's why I was telling this should be 4, okay, this is sine 18, okay, 2 times sine 18, okay, that's why I was confused that minus 1 plus under root 5 by 4 is sine 18 degree, but it is minus 1 plus under root 5, okay, so this is our answer, okay, third is the answer. Okay, now let's move on to the next question. Okay, the next question is question number, this question 49, okay, 49, which says if s denotes the sum of infinity and Sn, okay, denote the sum of n terms of the series 1 plus 1 by 2 plus 1 by 4 plus 1 by 8 and so on, such that s minus Sn is less than 1 upon 1000, then the least value of n is, okay, s power infinity is what, 1 upon 1 minus 1 by 2, which is nothing but 2, okay, very simple. Now Sn will be what, Sn will be, it will go on till 2 power n minus 1, okay, which will give me, okay, first let me write the series 1 plus 1 by 2, 1 by 4 and so on, so that you can understand, since it is beginning from 0, 2 power n minus 1 will be the last term, since it should have n terms. Then according to a into r power, which is 1 by 2, but it is less than 0, so 1 by 2 power n upon 1 minus 1 by 2, which will give me nothing but 2 into 2 power n minus 1 upon 2 power n, which is nothing but 2 power n minus 1 upon 2n minus 1. Okay, so we got this Sn. Further on, okay, what we can do, one more thing, is that s minus Sn is less than 1 upon 1000, right? So this is 2 minus 2 power n minus 1 upon 2 power n minus 1, it should be less than 1 upon 1000, giving me my answer, this is 1, this will become 2 power 1, this is 2 power 1, they will add on, giving me 2 power 1 minus 2 power n plus 1, should be less than 1 upon 1000, okay, so the bottom will be 2 power n minus 1, okay, so what we are getting from here is this will cancel out, be minus 1 upon 2 power n minus 1, 2 power n minus 1, okay, n minus 1, okay, that's why upon 1000. After this, what we will do, okay, we will multiply and move it that side, 2 power n minus 1 will be greater than 1000 if I multiply this side, okay, and since it is negative, sign will invert, okay, when I multiply by minus side and then I cross multiplied, okay, because n is a very big number, it will be greater than, but if I multiply, since it is less than, why, because negative sign will make it less than, okay, that's why, but when I multiply with negative signs, everything will get changed, okay. For now, it to be bigger, okay, we have to check some values, okay, if I check 2 power 10, it is about 1024. Okay, which is the appropriate value, means at 2 power 10 it is greater than, so n minus 1 should be greater than 10 for this to happen, greater than equal to 10. Okay, so n should be greater than equal to 11. Okay, so the least value of n is 11, so 4 is the answer. Okay, 4 is the answer. Now let's move on to the next page. Okay. The question number 50 is as follows. The first term of an infinite geometric series is 21. The second term and the sum of the series are both positive integers. Then which of the following is not the possible value of the second term? Okay, so first sum of the first term. Okay, so I know a is nothing but 21. Second term will be 21r and 21r square, 21r cube, and so on till infinity. Very simple. Now if I get the sum of infinity, it is nothing but, okay, now one more thing, the sum of infinity term, sum of the series are both positive, so sum of the series is what, 21 upon 1 minus r is positive, and 21r is positive. But to get 21r we should multiply here, because I can form here 21r, so 21 into 21 upon 21 minus 21r, but this should be positive, so we'll do one manipulation, take 21 outside, 1 minus r. Now check the values. Okay, now for it, okay, for it to be integer, okay, r should be less than 1, okay, but it should be positive, so we will do what, we will check the values 1 by r. If it is equal to what, if it is equal to 1, okay, then what we are going to get, 21 minus 21 r should be equal to 1, giving me minus 21, r is equals to minus 20, r is equals to 20 upon 21. Now it is right because it is less than 1, okay, less than 1, okay, and which is also a proper condition for a infinite GP, and it is positive also. Okay, so three conditions are satisfied. First, it is less than 1, and second, the GP condition, and the third, that 2r is positive. Okay, so we got 2r. Okay, we got this. Okay, this value is right. Now if I check for 21r as equals to 2, then what I'm getting, this will become minus 21r is equals to 23 minus 19. Okay, so r is equals to what, 19 upon 21. Okay, 19 upon 21. So what we can do, when I multiply, what I will get, 21 minus 19, which will give me 2 upon 21 into 21. Okay, but when I multiply this thing, 21 minus 20 upon 21 into 21, so here I am getting a proper integer, while here I am not getting a proper integer. Instead I will get a random value, okay, which will be like 21 into 21 upon this 21 minus 19, which will be 2, so 21 into 21 upon 2. Okay, so it will not give me a perfect integer. Okay, positive integer, I want integer. Okay, so I will try the third term, which is 21 into 1 minus r is equals to 3. 21 minus 21r, which give me 18, minus 18 into minus 21r, final answer 18 upon 21. Okay, so if I put here 21 minus 18, it is what, it is 3, and 21 into 21, so it will cancel out and give me an integer. Understanding what I'm telling? But here when I was taking 2, I was not getting an integer. Okay, now let's take 21 minus 21 r is equals to 4, giving me this as 17 minus 21 r, so our r is nothing but 17 upon 21. Now let's check this out. So 21 upon 21 upon, this will be 21 minus 17. Again you can see I am getting 4, which says this is not an integer, not a integer, so we will cancel this. Okay, so one thing is very clear, that at even term we will not get a integer. Understanding? So we will try the possible values, okay, which will give me. So like we tried for r is equals to 21 into 1 minus r as 1, we tried 3. Okay, so we got a proper idea that at odd numbers it is working properly. At 5, okay, at 5 it is what giving. Okay, at 5 it will be what, 21 minus 5 means minus 16, should be what, minus 21 r, giving me r is equals to 16 upon 21. So 21 minus 16 will be 21 into 21 by 5. Okay, this is not a proper number, so 5 will also be get rejected, and 6 will be rejected. 7, we will get r is equals to 14 by 21. Now here 21 minus 14 will be what, 7. Okay, 7 will cancel out 21 and we will get an integer. Okay, this problem is quite difficult to analyze. Okay, that you should analyze that after putting this term I will get integer or not. That is the difficult thing. Okay, so at putting 7 I am getting an integer. Okay, which is nothing but 7 3s are 3 into 21, 63. Okay, and let's check for 1 and 3. At what I was getting, at 1 I was getting something like, okay, at 1 I was getting r is equals to 20 by 21, giving me 21 minus 20 upon 21 into 21. Okay, this would be a very big number. Further on, when I used, okay, r is equals to 3, I got what, 18 by 21, which gave me 21 minus 18 is equals to 3 upon 21 into, so it's still a bigger number. Okay, now if I take r is equals to 9, okay, 7 8 is not possible since even number. 9 will give me what, r I will get what, minus 21, r is equals to minus 11, r is equals to 11 upon 21. My final answer 21 minus 11. Okay, 21 minus 11, which will give me 10. 21 into 21 by 10. Okay, so we'll cancel this out. Okay, let me check whether 21 minus 21 r is equals to what, 11, 9, which will give me, if I cancel this out, okay, this will be what, 12. Okay, sorry, this will be 12, not 11. Okay, so we are going to get 12. Okay, which will make it 12 by 21. Okay, that's why I was thinking. Okay, so we are got 12 by 21. So when 21 minus 12 will be happen, we will get 9, which will be divisible by this. Okay, so okay, we can divide it using 3 3s and then again 3 3s. Okay, so integer. Okay, now we want to check. Okay, so are these values valid? Now we will check whether means we are taking the possible values of second term. Okay, and we are hitting the r values using this sum formula of bottom one. Okay, now 2r of this, when I use 1, r1 is possible, so 2 will be my answer. 2 into r when r is 3, this 6 will be my answer. 2 into r when r is what, 5 is not 14 is my answer. 2 into r, okay, when r is equals to 2 9 is 18 is my answer. Okay, so the only number which is not present is 12. So 12 is the number not possible, okay, which they are asking. So 12 is the answer. Okay, now listen what we did. Okay, first is the answer. First we get the sum. Okay, that was the job. We got the sum. They told the first number is 21. We created sequence on the basis of that. They told that the second number is positive and the sum is positive. Fine, we multiplied it and we got here 21, which we should be positive. But after getting, they told that the That's the sum of the series but positive integers. Now the sum of the series should be positive integers. Since we have multiplied, it should still be an integer. Then we started considering terms r is equals to 1, r is equals to 2, at what it will be an integer, and then we came to know at even number it will never be an integer. Then we started checking at odd number. At odd 5 it also failed, but at 7, 9 it worked. Okay, and 2 are 2. Then we verified this number. Okay, we can go on till many terms, but since we wanted to find the second term, which means which value is not given, okay, which is not the value of second term possible. So this and this were possible, the only term was 12 not possible. Okay, so they will not give a very difficult question, they will just try to a little bit make it difficult like this, that you have to predict the term. Okay, seeing that this will be always positive. Now let's move on to the next question. Okay, the next question is as follow. Let me take out the question. Where is my question? Okay, this is the question, 51 question. Okay, which says the sum of infinite GP. Okay, sum of infinite GP is 57 and the sum of the cubes is 9747. Then the common ratio of the GP is, okay, so let's consider GP a plus ar square and so on, infinite. 57, fine. So a upon 1 minus r is 57. Now their cubes means a cube, r cube, r power 6, and so on till infinity is what, 9747. Okay, now if I take it sum, a cube upon 1 minus r cube should be what, 9747. Now I cannot divide this by this, so I will take cube on this, which will create it 1 minus r the whole cube, 57 cube. Okay, so we will do what, we will divide this will be bigger number, so we will divide 57 the whole cube upon 9747 upon what, this will be my first, a will cancel out, giving me 1 minus r cube upon 1 minus r cube. So here this I can write as 1 minus, this is basic property, a minus b, a cube minus b cube can be written as 1 plus r square plus r upon 1 minus r into 1 minus r square, into this will cancel out, giving me a value of 19. Okay, this you will have to do a bit calculation, okay, using a calculator. Okay, or you can, it will take lot of time, okay, because it is a difficult calculation. This will cancel out, giving me 1 minus r square plus 1 plus r upon 1 minus 2r plus r square into 19. Okay, then we will multiply this, okay, which will give me r square plus r plus 1 should be equal to 19 r square minus 38 r plus 19, which will give me 18 r square minus 39 r plus 18 should be equal to 0, giving me, if I break them, 3 minus 2 into 6 r minus 9 is equals to 0. So r is equals to 2 by 3 or r is equals to 3 by 2. But since it is an infinite GP, so mod r should be less than 1, which is only possible in this one because it is greater than 1. Okay, so this will get cancelled out and this will be rejected, which will be the possible value. So r is equals to 2 by 3. Okay, this question was nothing but just here was the part that you cannot divide it directly, you have to use the cube, okay, to cancel out this. Otherwise, okay, now we can break this. Yeah, we can break this as 1 minus r into 1 plus r square, sure, but a will make you trouble, that a square will always be in the equation. To avoid that, we did the cube. Okay, so rest of thing was calculation. Okay, now let's move on to the next question. Let me take the next question. The next question is 52, okay, which is this question, okay, which says if SP denotes the sum of the series 1 plus RP plus R power 2P and so on till infinity, and a small p, okay, small p, the sum of the series 1 minus RP plus R power 2P minus R power 3P and so on till infinity, mod R is less than 1, then the sum of capital SP and small sp in terms of S2P is, okay. So first get the capital SP, 1 upon 1 minus RP, very simple. Small SP, here common ratio is minus RP, so 1 upon 1 plus RP will become. Now if I add them, since what they are asking, SP plus small sp will be what, 1 upon 1 minus RP plus 1 upon 1 plus RP. Here I will multiply with 1 plus RP plus 1 minus RP to make the base same, 1 minus RP into 1 plus RP, which will give me 2 upon 1 minus R2P. Okay, a square minus b square the whole square. Now S2P, if I try to create 1 upon 1 minus R power 2P on the basis of this. Okay, so this is my S2P, but if you observe it here 2, it can be written as 2 into 1. Okay, so 2 into S2P will be this SP plus small sp. Okay, so this was just a bit calculation type question. Okay, not anything, just you need to get the sum. Here you need to identify that the ratio is negative. Okay, we have done many problems where ratio are negative, and I have told you that ratio can be negative, D cannot be negative in AGP, that thing also, but it has nothing to do with this thing. Okay, and one more thing, this sum. Okay, this thing, sum stuff. Okay, we calculated it and then we equated with the S2P. Okay, but you should know the generalized equation after when we get. Okay, some child, what they do, they put here 2. Why they do put 2 here, I don't know. Okay, they try calling it the whole S2P. I have seen many children doing this mistake. Please avoid that mistake because it is very wrong. Okay, you are doing mistake. Okay, straightforward mistake. Okay, with no logic. Okay, so 1 is the answer. Okay, now let's move on to question number 53. Okay, question number 53 is this one. Okay, this one, if the sum of the infinity of the series 1 plus 2r plus 3r square plus 4r cube and so on is 9 by 4, then the value of r is. Okay, and this question should you should do on yourself, because this question is AGP straightforward question. Okay, and we have done more worst type of questions of AGP in when we were learning sequence and series, and this is just a piece of cake in compared to that. Okay, 9 by 4 is given the sum. Okay, let's take it as S. Okay, first try it, but first you should try. Okay, this question I will, if you cannot do it, then it's very sad news for you. Okay, means you are not learning anything properly. Then I will multiply with common ratio, which is r. Then this will be r, this will be 2r square 3r cube. Okay, this was the method to solve AGP, because this is in AP and this is in GP. AGP 1 minus r into S, r square r cube and so on till infinity, and this will become 1 upon 1 minus r, giving me S is equals to 1 minus r square. Okay, and I know S is 9 by 4, so I can write it 1 upon 1 minus r. Till here you should be crystal clear, means you should do it on yourself till here. Okay, if you get stuck in calculation, it means your calculation is weak. After this, okay, we will take, this will become 3 by 2 1 upon 1 minus r. Okay, which will give me my answers. Okay, this will be plus minus 3 by 2. If I consider 3 by 2 upon 1 minus r, my answer will be 3 minus 3r is equals to 2, giving me 1 by 3 is equals to r. And if I consider it like this, minus 3 by 2 is equals to 1 upon 1 minus r. Okay, my answer will be minus 3 plus 3r is equals to 2, giving me r is equals to 5 by 3. Okay, so which one is correct? Okay, here r is greater than 1 and r should be less than, mod r should be less than 1 for infinite GP. So this one is correct and this one is rejected. Okay, so this condition of mod, it looks very pathetic when we were studying sum of infinite GP, but now you can see it is of great importance. It comes in use always. We get two values, okay, after solving quadratic or like these thing questions. Okay, now 1 by 3, 2 is the answer. Okay, okay, now let's move on. Okay, the next question is this question number 54. Again, this is a series type problem. Okay, and you should do it on yourself. Okay, because series type problems we have done very detailed. Okay, take it as series 1 plus 4 by 5, 7 by 5. And what is this special means? Special type of series type problem. Okay, and so until infinity it is in AP. D is constant, which is 3, and ratio is what? 1 by 5. Fine, we got this thing. We multiply with the ratio, we just move the one term and try to create the same thing, and so on till infinity. If I cancel out, 4s by 5 will be my here, 1 plus 3 by 5, 3 by 5 square, 3 by 5 cube, and so on till infinity, giving me okay, so 1, okay, 1 upon 1, okay, 1, our answer will be, okay, here, okay, you can take any of the GP, doesn't matter. Okay, 1 plus 1 minus 3 by 5, giving me what? 5 minus 3 means 5 by 2. Okay, which will give me, okay, I think we have did a mistake. It will become, okay, this is 1, sorry, okay, this is 1. Okay, we will take the series from here, 3 by 5 into 1 minus 3 by 5. Okay, sorry, 1 by 5, which will give me 1 plus 3 by 5 into 2 into 5, which will become my what? This will cancel out, and this will be what? 3 by 2. 1 plus 3 by 2 is nothing but 3. This is what? 3 by, okay, 4, sorry, 1 by 4 it is. 3 by 4, this will become 7 by 4. Okay, and here it is 4s by 5, so our s will be what? 35 upon 16. Okay, so this is our answer. What we did, okay, what mistake I was doing was it was 1, it has didn't have 3, it would have 3, then our thing will be right. Okay, I just saw that. Okay, then I did that mistake. Okay, and then consider it, but I got a click that I should not take it. Okay, I have told you that in this AGP sometimes this occurs. Okay, what you have to take it in series or not, that you have to make out, okay, by yourself. Okay, that comes by practice. Okay, so I make out that it will not be included. I separated them and then solved and got my answer, which was 35 by 16. So 4 is the answer. Okay, so 4 is the answer. Now let's move on to the next question, which is question number 55. Okay, question number 55 is this question. Okay, this is the question which says s is equals to, okay, this I can write as 0.10, this I can write as 10 by 3, this I can write as 10 by 5, this I can write as 10 by 7, and so on till infinity. Again, it is a series, special series type questions. You can clearly make out it is a AGP, and common ratio is 10 by 2, so I am multiplying it and getting 10 by 3, 4 by 10 by 5, 6 by 10 by 7, and so on till infinity. If I subtract, I get 99s by 100, 2 by 10, 2 by 10 cube, 2 by 10 power 5, 2 by 10 power 7, and so on till infinity, giving you a final answer 2 by 10 into 1 minus 1 by 10 square. Okay, which will be 2 upon 10 into, this will be 10 square, this will be what? 99. This 10 will cancel, 2 into 10 upon 99. Okay, and here if I move this that side, which will give me 2 into 10 means 2 into 1000 upon 99 into 99, which will be, okay, 99 into, which will be 2000 upon 9801. Okay, so this gives our s, okay, which is nothing but s is equal to 20,000, 2000 by 901. Okay, so 2 is the answer. Okay, this question has nothing to be explained. Okay, these 3 questions which came in special series, okay, you should do on yourself. Okay, because that is very easy questions. Okay, now this question, the positive integer n for which 2 into 2 power 2 plus 3 into 2 power 3, 4 into 2 power 4, and so on, plus, and the n into 2 power n is equals to 2 power n plus 1. Okay, how you need to solve this? Okay, now it is very clear that, okay, it is a AGP. Okay, and how you will solve it, that, okay, the ratios, okay, 2, 3, and the difference is 1, the ratio is 2. Okay, common ratio is 2, so I will multiply it by, okay, I will first call it as s, that is the first step. Okay, okay, n into 2 power n, then 2 into s will give me 2 into 2 power 3, 3 into 2 power 4, and so on. What will be the last term? N into 2 power n plus 1. And if I subtract, I will get minus s is equals to 2 into 2 power 2, and this will become 2 power 3, this will become 2 power 4, and so on. What till 2 power n minus 1, and minus plus and minus will be n into 2 power n plus 1. And here what I will do, I will break it, since I have told you have to specify how many terms you can. So here I can write it 2 power 2 plus 2 power 2 into 3, 2 power 3 plus 2 power 3 plus 2 power 4, and so on till 2 power n minus 1. So it is what? N minus 1 terms. Okay, it is what? N minus 1 terms. Okay, it is how many terms? N minus 1 terms. Okay, so what we can do? Okay, sorry, this will be n till n. Okay, till n. Okay, then it will be n minus 1, then it is n plus 1. Okay, now 2 power 2 will be left, and this will be okay, the first term is 2 power 2, which will be 2 power 2 into 2 power n minus 1 upon, this will become 1. Okay, minus n into 2 power n plus 1. Okay, which will give me 4 plus 2 power n plus 1 minus 2 power 2 minus n into 2 power n plus 1. So this and this will cancel out, giving me my final answer 1 minus n into 2 power n plus 1. Okay, this is minus s, and we know the s is nothing but 2 power n, so minus 2 power n plus 10. Okay, and here if I give this minus sign to this 2 power n plus 10 will be what? N minus 1 into 2 power n plus 1. Okay, and what we can do, we can do one thing, that okay, a little bit of manipulating thing. Okay, but you should be able to understand, that is I can write, okay, I can write this thing as in this manner to make it simple. Okay, okay, I can do a little bit of manipulation. Okay, which is that I can do one thing. This will be what? N minus 1, this was n minus 1, n into 2 power n minus 1. Okay, we can break it this thing. Okay, we can break this thing as 2 power 10 into 2 power this, and this has n minus 1 into 2 power n into 2, which will, this will cancel out, giving me my final 2 power 10 is equals to 2n minus 2. Okay, which will give me 512. Okay, 512, this should be 512 and plus 2 and divide by plus 2. Okay, it should not be 512, it will be much more greater, which will be approximately 1024. Okay, 1024 plus 2 and then divide by 2 will give me my n, which will be nothing but n is equals to 513. Okay, so this is our answer. Okay, which is fourth is the answer. Okay, and this question was again a series, special series type question. Okay, nothing great, we have done special series type question in much detail. We have seen this type of variety of question even tougher than this. Okay, now the next question is based on the complex number, which says if omega is the complex nth root of unity, then summation r is equals to 1 to n a r plus b omega power r minus 1 is equals to what? Okay, where first is n into n plus 1 a by 2, second is nb upon 1 minus n, third is na upon omega minus 1, and so on. If I open the summation, what I get? A plus b. Okay, this will become 0. This will become what? This will become 2a plus b into omega, 3a plus b into omega square, and so on till what? Till what? Na plus b upon omega n minus 1, right? This will be what? This will be my Tn. Okay, Sn. Then okay, so what I can do? Okay, I can separate it out. A plus b plus 2a omega plus 3a omega square plus 4a omega cube, and so on. What will be? I can break it into two series, into na, the last one, na into omega power n minus 1. Similarly, I can break this one b into omega square, and so on till b into omega power n minus 1. So we will do what? We will take a common from this series and bring this b with this series. We will be left with 1 plus, okay, 2 omega, 3 omega square, 4 omega cube, and so on till n omega power n minus 1. Plus, if I take b common here, omega plus omega square, okay, 1 plus omega square until omega power n minus 1 will be left. Okay, so what I can do after this, we will do one thing. Okay, we will take its sum. Okay, we will take, and you should know that omega power n is equals to 1. Okay, this is the property of nth root of unity. Okay, we will discuss that in, okay, I have used this property when we were solving short problems, okay, and learning sequence and series, that omega power n is equals to 1. Okay, this will be as it is, 1 plus 2 omega plus, okay, this is very obvious, it is a AGP, okay, with n into omega power n minus 1, and this will become v into 1 into omega power n minus 1 upon omega minus 1. But I have just told that omega power n is equals to 1, which will make it b into 0, which is 0. Okay, now we will deal with this one. So our s is a into 1 plus 2 omega plus 3 omega square, and so on till n into omega power n minus 1, right? I will take it some other series. We have done this type of problem also when we consider to make the problem easy, we consider a series as a different series in one, because otherwise it will become complicated. Okay, so we want to solve this, okay, and it is a AGP. Okay, so how we can solve this? Okay, how we can solve this? The way to solve this is that multiply with common ratio omega into s1 will be what? Omega plus 2 omega square, and so on, plus last one n into omega power n. Okay, which will give me, okay, I will take the next page, which will give me 1 minus omega s1 should be equal to 1 plus omega square, and so on. The last one be omega power n minus 1 plus, okay, with plus sign, and then this will be what? With minus sign, minus n omega power n, because this will not get cancelled out. After this I will take the sum of this 1 to omega power n minus 1 upon omega minus 1 minus n into omega power n, and here you can see this will again become 0 because omega power n is equals to 1, and this will be left, and this is 1 minus omega into s1. I will move it that side, which will give me s1 is equals to minus n omega power n upon 1 minus omega, which will give me s1 is nothing but, if I take minus outside, will be n omega power n upon omega minus 1. Now we know the s was a into s1, we know the s1 value a n into omega n upon what? Omega minus 1, but omega power n is nothing but 1, so a n upon omega minus 1 is our answer, which is this, which is nothing but third option. So third is the answer. Okay, we have done each and every step, okay, as we have did in AGP. If you know the AGP, this, okay, it breaks into two series. Okay, if you know the AGP solving, you can do this. And the next was a simple AGP, but we know omega power n is 1, because of which it cancel out, so 0. And after that the last thing was this, and we have also did this type of question in which we discuss in between, take a different series as a sum s1 and then solve it and put the value. So it was nothing but a surprise type question for us, which were studying with me. Okay, now let's move on to next question. And we did so many questions, like now your base will be quite strong, okay, compared to other students. Okay, now this is the question, which says question number 58, which says ABCD is a square of length a, and a belongs to natural number a greater than 1. Let L1, L2, L3 and so on be points on BC such that BL1 is equals to L1, L2 is equals to L2, L3 and so on is equals to 1, and M1, M2, M3 and so on be the points on CD such that CM1 is equals to M1, M2 is equals to M2, M3 and so on till 1 is equals to 1. Then summation n is equals to 1 to a minus 1, where a ln the whole square plus ln mn the whole square is equals to what? Okay, so let's consider a square first of all. Okay, to solve this problem, let's consider a square. Okay, because this problem is not simple as it looks. If you remember, we have done a triangle problem. Okay, it will make you a little bit feel like that. Okay, but it is different. Okay, these questions comes in other books in a similar way, but something differs. Okay, like here it is telling L1, L2, L3 and so on. This last will be n minus 1. Okay, that is the trap part, and here will be 1 2 3 4 5 6. Because of it will have, if I broke it in n plus like this, see, they have told 1 1 1, then the whole will be add on and give me n plus 1. Okay, that is the trick part. Okay, you should remember it. Okay, remember this, because children cannot able to count 1 2 as like this. Okay, so just remember the last will be n minus 1, and the thing will add on will give me n plus 1, because in sequence series questions on triangle based on this, question on square, rectangle, they continuously ask this stuff. M1, M2 and the so on, last will be mn minus 1, and the whole will be what, n plus 1. Okay, we are done with this. Okay, when we count from here, if you count from here, it will be n. Okay, so because the last one becomes this d, that's why it is m minus 1. Okay, I told you that also. Okay, fine. Now what they're telling, a l1 into a m1. Okay, and what they're telling, ln. Okay, ln, n is some value. Okay, that's why the a minus 1. Okay, and side length is a. Okay, a minus 1 will be the last, is what, mn minus 1. Okay, like this they are telling. Okay, the last, so you have to add on and get the values. Okay, so now we will solve this by method 1, and then we will solve this by method 2. First, method 1. Method 1, here you consider triangles. Like if you open the summation, you will see a l1 the whole square plus l1 m1 the whole square plus a l2 the whole square plus l2 m2 the whole square, and so on. What will be the last one, a minus 1 the whole square plus l a minus 1 into m, that is n minus 1. Okay, but they are writing m minus 1 the whole square. Okay, now we will write the values separately and then add on. Okay, because it will create otherwise confusion. Plus l1 m1 the whole square. A l1 we want. Okay, if you observe, this as being a right angle triangle, we want this length. Okay, for that we know this a, we know it is unit length, so we can write it a square plus 1 square. Fine. Okay, now for l1 m1, for this is a rectangle triangle like this. Okay, we want this length. This is what, this length will be a minus 1, because here one distance is left, a minus 1, and this will be 1. So this is what, a minus 1 the whole square plus 1 square, which gives me a square plus a minus 1 the whole square plus 2. Now let's take the second one, a l2 the whole square, l2 m2 the whole square, which is nothing but a l2 will be this thing and this thing, again a square plus 2 square plus a minus 2 the whole square plus what and this was 1 square, this will be 2 square, a square plus a minus 2 the whole square plus 2 times 2 square. Okay, and similarly we will do a l3 the whole square plus l3 m3 the whole square, which will be nothing but a square plus 3 square plus a minus 3 the whole square plus, now you can write on the base of 3 square, which is nothing but a square plus a minus 3 the whole square plus twice 3 square. And if we write the a minus 1 the whole square plus a minus 1 into m a minus 1 the whole square will be what, a l1 a l minus 1, it will be again a square plus this. Now if you observe, this will be the last. Okay, this will be, so this will be what, a minus 1, so this will be nothing but a minus 1 the whole square, and here, okay, here we will have this one, and for this will be, so it will be a unit distance 1 square plus, and this will be again a minus 1 the whole square. Okay, so what we are doing, a square plus this will be 1 and this will be twice a minus 1 the whole square. Now if we observe, Okay, we move to n. Okay, if you observe, it was a how many times? A minus 1. This thing, a minus 2, a minus 3, and so on, it is decreasing to 1. Fine. This is twice 2 cube, twice 3 cube, and so on till the end, twice a minus 1. Okay, it is increasing and reaching the max value. So if I take the summation, which is a ln the whole square plus ln mn the whole square, which will be what? A minus 1 times a square. This is nothing but, if you see, a, okay, this is n square, n minus 2 square, n minus 3 square, and so on. Okay, it is sum of square of natural numbers. Okay, which is, so I can use this formula, n square in n into n plus 1 into 2n plus 1 for sum of square of natural number, and when I replace n by a minus 1, I will get my answer, which would be 2a minus 1 upon 6. So here if I add on, I will get a minus 1 into a into 2a minus 1 upon 6. And here if you see, it is again a sum of natural number, but 2 comes in picture. Okay, 2 into till a minus 1 the whole square. Okay, it is like this, 2 into, okay, if I take 2 out, 1 square plus 2 square and 3 square till what? A minus 1 the whole square. I will take its sum, which will be a minus 1, a into 2a minus 1 and by 6, and here will be what? 2, which will give me a minus 1 into a into 2a minus 1 upon 6. Okay, now let's move on. So next page, so our answer is a square into a minus 1 plus a minus 1 into a into 2a minus 1 upon 6 plus a minus 1 into a into 2a minus 1 upon 3. Now let's take a into a minus 1 common, which gives us a plus 2a minus 1 by 6 and 2a minus 1 by 3. Okay, so if we add on, this will be a plus, okay, this will be what? A is left here, 2a, okay, this whole will become 6, giving me here 6, 2a minus 1 plus 6a minus 3, okay, which will be okay, which will be what? 2, okay, which will be 2, okay, which will be 2, let me, okay, so here 6 will become 12 and this will become minus 2, giving me my answer. This will become 12a plus 14a, okay, 6 12 plus 2, okay, 14a. Okay, we should first calculate this thing because it is more easy. Okay, this thing, this between one, a plus 2a means 4a minus 2 upon 6. Okay, this will become 6a, which will give me, okay, 2a minus 1, 6a minus 3 minus 2, okay, this will be 4. This will give me 6a minus 3, okay, minus 3 upon 3 upon 6, okay, so which will give me 2a minus 1 upon 2, and here I have a, so 2a plus 2a minus 1 upon 2. So our calculation becomes easy, which gives me 4a plus minus 1 upon 2. So if I put here, I will have a into a minus 1 into 4a minus 1 upon 2. So which you can see, is there any option? I guess our answer is wrong. 4a. Okay, 2a. Yes, the third is the answer. So it was a very difficult question. Okay, now let's do it by method 2. Okay, method 2 is direct method. Okay, method 2 is direct method. Okay, which you will come out like this. Okay, first I will find a ln the whole square. Okay, a ln means finally directly the nth term. Okay, directly the nth term square. Okay, which you can see if I take here. Okay, if I take here. Okay, if you calculate, okay, in here you have to calculate here in different sense. Okay, we are calculating the gaps. Okay, it is n plus 1 gaps, so just before it will be n gaps, and here it will be a square, so it will be a square plus n square. Fine. Now we are calculating ln into mn the whole square, which will be, okay, this will be what? Okay, this will be what? L, it is moving from ln. Okay, ln to this. Okay, gaps. Okay, we are considering in terms of gaps. Okay, ln gaps to mn gap. Okay, mn gap. Then here you will see that its length, okay, will be what? N gap, a minus n gap. Okay, although we can call it as 1, but we will write it a minus n. Okay, that's why this method is not easy to click. Okay, a minus n the whole square plus, and this will be what till here, just one leave this, it will be n square. When you open this you will get a square. Okay, you have to add this, you will be a square plus n square again minus 2a n plus n square, which will give me 2a square plus 3n square minus 2an. If I will apply submissions, n is equals to 1 to n a minus 1, which will give me what? Which will give me here 2a will move out as it is a constant. Here a minus 1 will be added till a minus 1 times, 3 times a minus 1, here a, and 2a minus 1, since we are applying n square sum of n square formula, and here will be 6 minus 2a minus 1 into n into a upon what? 6. No, 6 not 2. Okay, so what we are getting? 2a square a minus 1 into a minus 1 into a into 2a minus 1 by 2, giving me a square into a minus 1. Okay, this is what? 2a n is giving me this a minus 1 into a 2a square into this. If I take a into a minus 1 common, okay, what I am left with? 2a plus 2a minus 1 upon 2 minus a. If I take this 4a plus 2a minus 1 minus 2a upon 2, which will give me 4a minus 1 upon 2 into a minus 1. Okay, so here you can clearly see we are getting the same answer again, a into a minus 1 into 4a minus 1 by 2. Okay, so this is our answer again, same answer. Okay, which is this one. Okay, so we are done with 58 problem. Now let's move on. Okay, the concept is important. Here we are taking in terms of gap, here we are taking in terms of points. When we take points it is n minus 1, when you talk about gaps it is n plus 1 gaps. In triangle, gap concept was used. Okay, fine. Now let's move on to the 59th problem. Okay, which is this problem. Okay, this problem is very tricky problem. Okay, if you're very smart, you can solve it. Okay, and I have told you that how to solve this type of equation, 2 1 upon 2, how to get add 2 into 2 plus 1 upon 2, which is nothing but 5 upon 2. Okay, like this you have to solve. So 5 upon 2. Okay, you have to solve it like this, 5 upon 2, and the next will be what? 20 upon 13 plus 10 upon 9 plus 20 upon 20. The last one is given simple one. Okay, and so on. Now, okay, it is just means your depends upon intelligence to solve this question. That if you take if you multiply, okay, you can make this tens. If you multiply it by 4, this will become 20 by 8 plus 20 by 13. If you multiply it by 2, 20 by 18, 20 by 23, and so on. Okay, and now if you take the reciprocal of this 8 upon 20, 13 upon 20, 18 upon 20, 23 upon 20, it is just a means it just depends upon your observation that you can understand that the reverse, okay, gives you a constant 20 number and these terms are in AP. Okay, if you can observe that, then your job is done. You can take 20 common, a plus 13 plus 18. Okay, these are all in AP with D23 with D5. Okay, then you can get the Tn, which is nothing plus 8 plus n minus 1 into 5, which will give you 5n plus 3. Okay, but this will be what we want the term, that's why we are writing this. Okay, this is in terms of series, we are considering it in sequence, then we are getting the Tn, and 120 will be multiplied with this also, with this Tn term also. Okay, the last term we will add 15 here, which will give me 1 by 20 into 5 into 15 plus 3, which will give me 75 plus 3 upon 20. Okay, which will give me 78 by 20. Okay, so we got our answer. If you think that we got our answer, then you're wrong. We have reciprocal the series. Okay, the answer will be 20 upon 78. Okay, which will be nothing but 10 by 39. Okay, so 1 is the answer. Okay guys, 1 is the answer. Now let's move on to the last question. This was just that if you able to observe that the reciprocal of the terms, if I multiply with particular term, I can make the constant denominator same and get them in an AP. Okay, that is this. So please solve it 2 or 3 times. Okay, then only in exam you will be able to click this type of questions. Okay, that is a recommendation I will say. Now the last question, which is the 60th question, which says if a1 comma a2 and still so on till an are in HP. Okay, and a1 upon a2 plus a3 and so on till an, a2 upon a1 plus a3 and so on till an, and an upon and so on till an minus 1 are in what? Okay, first thing you can observe that here a1 is there, a1 is missing, a2 is there, a2 is missing, an is there, an is missing. So one thing I can do is a1 upon 1 upon a2. Whenever HP comes, this step is very general. Are in HP, are in AP, sorry. I will multiply with some of these numbers. I can multiply with a constant number. I can multiply it with the constant number, so I will multiply with some of these numbers. Natural number 1 plus a2 plus till so on till an upon a1 comma a1 plus a2 and so on till an, a2 comma and so on a1 plus a2 till so on till an upon what? A3, and similarly we will move on. We will come to know that a1 plus a2 till so on upon an. Okay, so I can remove this term 1 plus a2 upon a3 and so on till an upon a1. Similarly I can do a1 plus a3 upon so on till an upon a2 and plus 1, a2 will cancel out. Similarly here we can do a1 plus a2, a3 will not be there, a4 until so on till an upon a3 plus 1, and the last will be what? a1 plus a2 and so on till an minus 1 upon an, and a1 will cancel out. Now we will add minus 1 to all. We can add, multiply with any constant number, it will still be an AP. Okay, which gives me a2 plus a3 and so on till an upon a1 comma a1 a3 and so on till an upon a2 a1 plus a2 a4 upon so on till an upon a3, and the last one will be a1 upon a2 and so on till an minus 1 upon an, and are in what? AP. So if I take here what we have reverse of them, so we will reverse them. When we reverse them, a1 upon a2 plus a3 plus so on till an comma a2 upon a1 plus a3 and so on till an, and like this we will do, and an upon a1 plus a2 and so on till an minus 1 are in HP. Okay, so we are done with these problems. Okay, and we will continue with this exercise. Okay, uh, left question. Okay, in the next problem solving course we will do some more 20 questions, and we will continue till we complete the exercise. Okay, and then we will solve institution level questions, okay, which given in some institution books, and then we will take some special examples and inequalities. Something extra still has to we have to teach, that is inequality. I have not forgotten anything. Inequality are still to be in detail, and exponential and logarithmic series the problems. Okay, problems also on one more thing, that is logarithmic series, and one more trigonometric. Okay, we will do that in trigonometry chapter. Okay, till then take care. Okay, and see you in the next time. Okay.